You see it, that little dark, watery spot on the leaf of your absolute favorite orchid, and your heart just sinks. In, what, a day? It's bigger, it's blacker. And you're asking yourself that one question every single grower dreads. Is this it? Is this a death sentence? Well, welcome. Today, we're taking on black rot, which is, no joke, one of the most vicious threats to our orchids. We're going to break down all the dense, scientific stuff into a clear, step-by-step guide for the orchid emergency room. And by the end of this, you'll have the tools to turn that panic into a solid plan and actually save your plants. All right, let's get into it. So, first things first, you have to know your enemy. The problem is, this attack starts really quietly, almost looking like nothing. And that's why spotting it early is so critical. Okay, now what is genuinely terrifying about this is the speed. I mean, those little watery spots you might see on Monday can just explode into these dark, purplish-black nightmares in less than 48 hours. The tissue gets all soft and watery, and you'll often see this really distinct yellow halo around the edge. You know what that halo is? That's the battlefront. That's where the pathogen is actively mowing down healthy cells. This thing can move through your plant centimeters a day, and it can cause a total collapse in as little as a week. It is no joke. So you see this, you freak out, and you grab your go-to fungicide, right? You spray it, but the rot just keeps spreading, and you're wondering why. Well, it's because you might be fighting the wrong enemy entirely. And this is the question that changes everything. We've all been kind of conditioned to think it's a fungal disease, but what if the real bad guy is just an imposter? And here it is. This is the absolute key to the whole puzzle. Black rot isn't caused by a true fungus. It's caused by things like Phytophthora and Pythium. And these guys are oomycetes, or water molds. Get this, genetically, they're way closer to algae than they are to a mushroom. And that little biological fact, it means everything.
And this chart shows you exactly why that matters. Just look at the cell walls. A true fungus has a cell wall made of chitin. And guess what most fungicides are designed to attack? Chitin. But an oomycete, our water mold, its cell wall is made of cellulose, just like a plant's. So your standard fungicide, it's completely useless. It's like you're bringing the wrong weapon to the wrong war.
Okay, so let's put on our lab coats for a second. To win this fight, you've got to think like a plant clinician. You have to make a confident diagnosis, and that means ruling out a few common things that look kind of similar. This chart right here is your best friend. Seriously, look at the differences. Black rot is soft and watery, sure. But bacterial soft rot, that's truly mushy, and here's the dead giveaway. It has a foul, like dead fish smell. Ugh. Black rot is pretty much odorless. And then you have calcium deficiency. It can look black, but the tissue is dry and firm, and the edge is super sharp, no yellow halo. Use these clues, you'll make the right call. All right, once you've confirmed it's black rot, time is your biggest enemy. There's no waiting around. The first and honestly the most critical response is immediate surgery. And you've got to follow this protocol exactly. Sterilize your blade with a flame until it's glowing red hot. That is not optional. When you make the cut, you have to remove all the black stuff, plus at least a 1-inch margin of what looks like perfectly healthy green tissue. Now, why so much? Because the invisible little filaments of this pathogen, the hyphae, they've already grown way past the damage you can see. Your final cut has to be pristine green, no discoloration at all. And then you seal that wound up tight. So, with the bulk of the infection gone, it's time for post-op care. We need to treat that wound and fight any of the infection that might have already spread inside the plant. And believe it or not, your best wound sealant is probably sitting in your kitchen cabinet right now. It's cinnamon. Now yeah, it's antimicrobial, but its real superpower here is something else entirely. Its most critical job is being a desiccant. It aggressively sucks water out of the wound, drying it out and creating this hostile aired environment where this water-loving pathogen just can't survive. It's basically a natural cauterization. But, and this is a huge but, a critical warning. While cinnamon is a total lifesaver on leaves and stems, it is a killer on roots. Its powerful drying action will fatally dehydrate the sensitive tissues of healthy orchid roots and just destroy them. So only apply to the wound itself. Never, ever use it as a root drench. Okay, for a really bad infection, one that's probably gone systemic, surgery by itself often isn't enough. We need to call in the big guns, chemical support. This number, 50%, is a big deal. It represents how much you can slow down the growth of Phytophthora with a systemic chemical called phosphatyl aluminum,
often sold as Aliette. It shows that the right chemicals can fight the infection from inside the plant.
But you can't just use one chemical over and over. The pathogen will eventually figure it out and develop resistance. That is why it is absolutely critical to rotate your treatments between different frat groups. Think of it like a boxing match. If you only ever throw a right hook, your opponent is going to learn how to block it. As you can see here, each group number is a different kind of punch. One messes with RNA, another attacks the cell wall. By rotating, you keep the pathogen guessing, and you keep your treatments working.
So we've spent a lot of time in the emergency room. Let's move over to the wellness clinic. Because the ultimate goal, really, is to build an orchid that is a fortress. One that can fight off an attack before it even gets started.
And this right here gets to the heart of prevention. The science is totally clear on this. A stronger, better-built cell wall acts like a physical shield that the pathogen literally can't break through. It's that simple.
So, how do we build that wall? It really all comes down to calcium. Think of calcium ions as the mortar that holds the cellular bricks together. But there's a catch. Calcium can only move through the plant when it's transpiring, when it's breathing. In a humid, stagnant room, transpiration slows to a crawl, and the plant can't get that calcium to its new growth. The solution? A fan. A simple fan. Good air movement powers the engine that delivers the calcium to build those strong, rot-resistant cell walls.
So, back to our first question. Is black rot a death sentence? It doesn't have to be. Not at all. By understanding the true nature of your enemy, by acting fast with surgery, and by proactively building a stronger plant, you change from being a worried plant owner into an effective plant clinician. You are your orchid's best defense. The only question left is, are you ready?